Okay, so our input is the same as day one. Those steps that we just went over in your anticipatory set. Decide the unknown value, turn the other quantities into terms of that variable, write an equation, solve. Okay, so now we're in the modeling portion. Now I'm going to show you the other type of problems. So today you might get a problem that talks about objects or things going in the same direction. So let's put same direction. I'll teach you same direction first. Same direction. Write that down. Here we go. It's kind of long. You're going to bear with me and we're going to be linguistic. Number one. A train leaves the station at 1 p.m. Write it down. A train leaves a station at 1 p.m. Now you'll want to take good notes today because some of these problems might be super similar to ones in the homework problem. I'm just putting that.
Should be exact.
Shh. It travels at a constant rate of 72 miles per hour. Miles per hour, MI per H. A high-speed train leaves the same station an hour later. A high-speed train leaves the same station 1 hour later. That train, it travels at a rate of 90 miles per hour. It travels at a rate of 90 miles per hour. The second train follows the same rate as the first train on a parallel track. I know. Bear with me. We're finally to the question. In how many hours will the second train catch up with the first train? While you're writing, I'll read it to you again. A train leaves the station at 1 p.m. It travels at a constant rate of 72 miles an hour. So think one train's leaving, woo, woo, shh, they leave at 1, it's going 72 miles an hour. Then you have a high-speed train, woo, woo, it leaves an hour later, shh, but it goes 90 miles an hour. University of Texas, please welcome Mrs. Valenta.
Welcome to the University of Texas, Mrs. Valenta.
So the second train leaves, boom, at 90 miles an hour. Now the second train follows the same rate as the first train on a parallel track. You know what parallel means. So So now we have to figure out how many hours it'll take for that train to catch up to the second train. So in a word problem, the first thing you have to do is go back and look at your key words, right? So take another color, different color, and let's underline our key things that we need to know. So, the train leaves the station at 1 p.m. It travels at a constant rate of, what's our first number? 72 miles an hour. So I'm going to underline that. Do the same. A high-speed train leaves the same station 1 hour later. Oh, there's another number, an hour later. It travels at a rate of, there's another number, 90 miles an hour. So you can see, if you can identify the numbers that are in the problem, you'll be good. The second train follows the same rate as the first train on a parallel track. Okay, that's just information. How many hours? Okay, so we're finding hours. How many hours? I know that I'm going to put my answer in hours at the end. How many hours will the second train take to catch up to the first train? Whew. So, I know it looks complicated. But first, we need to set up a little key for ourselves. Okay, so let's figure out what we're going to use the variable for. Well, we need a variable for the first train. So let's call that T. Is it T for train? All right. So we're going to make T equal the first train. Now, we need a variable to represent the second train. But what's different about the second train? Did they leave at the same time?
Nope.
Second train left an hour later. So if you're leaving later, it's going to be T minus, it's 1 hour behind. Think behind, negative. So T minus 1 is going to be the second train. The second train left an hour later. So it's an hour behind the first train. So what time did that train leave? The first train left at 1 o'clock. The second train left at what time? 2 o'clock. Okay, so it's an hour behind. Okay. Now, the formula that you're going to use is distance, because we're looking for distance. Distance equals the rate times the time. That's the formula we're going to use. Distance equals rate times time. So in these type of problems, to organize your information, you're going to kind of want to make a table. Okay, so I'll show you. So for this type of problem, I'm going to want to make a table. So I'm going to label over here train. I'm going to label rate, how fast it goes, time, and distance. Now we know that distance is rate times the time, right? That's what the formula tells us. So I'm going to put a little X here so I know that the train, the rate, and the time times each other is going to give me the distance. Okay, so let's put the first train down. First train goes, so I'm going to put train number 1. Goes at a rate of how many miles per hour? 72 miles per hour. Now, what did we represent for time? What variable? T. So how do I get the distance? Right here. Rate times time. But 72 times T. 72 T. So that's the distance of train 1. Train number 2. How fast does that train go? 90 miles an hour. What did we say represented the second train? T minus 1. So if I multiply, because rate times time is distance, I set it up here. So what's 90 times T minus 1? Well, let's just 90 times the quantity of T minus 1. Does everyone see where I got those numbers? Yes. Okay. So now I have to think of an equation to set up. Now, I know that we want to find out if the distances are going to match up. So, let's take the distance of the first train, 72 T, and see if that is going to be equal to the distance of the second train. See if they're going to catch up to each other. 90 times the quantity of t minus 1. So I just put them on each side of the equal sign together. Okay, I look on my equations now. The left side is completely okay. But my right side needs to be simplified, so I need to distribute. Just like a normal algebra problem that we've done. Write that down, draw your arrows. So I have 72t equals 90 times t is 90t. Bring down my subtraction sign or my minus sign. 90 times 1 is 90. So now what I need to do is, again, isolate my variable. Okay, so I need to subtract 90t from both sides. You have to get the variables on both sides. Subtract 90t. Positive 90t and negative 90t cancel out. So now I have 72 minus 90t, same signs add and keep, different signs subtract. They're different signs, so I'm going to subtract. 90 minus 72 is 18. And I have to keep the sign of the higher number, so it's negative 18t equals 90. Negative 90. That's what I'm looking for here. Negative 90. Okay, so again, simple algebra. Divide both sides by negative 18 to get t by itself. Negative 18 over negative 18 cancel each other out. Remember, you want to take good notes because it's almost like something in your homework. So, t equals 5. 90 divided by 18 is 5. But I'm not done. I found that the first train, it takes 5 hours. The second train, if I look back at my equation, I said the second train is t minus 1, right? So the first train is t. My second train is t minus 1, which is 5 minus 1. So that's 4. So in conclusion, I can tell my answer because it asked me how many hours will the second train take to catch up to the first train. The second train will catch up to the first train in 4 hours. That number 4 that we got. So the second train is going to catch up to the first train in 4 hours. No, the word problems are a lot of work. Find the key words in the paragraph or question. Set up the key, set up the equation, solve. So for these kinds of one that talk about same direction, make sure you make a little table, it'll help you, okay? The next thing I'm going to talk about with you is round trip. Okay, so go ahead and label the next one round trip. Round trip. Okay. So Miss Graham drives into the city. Miss Graham drives into the city to buy a new iPhone 6. At the store. Miss Graham drives into the city to buy a new iPhone 6 at the store. Because of traffic, she averages only 15 miles per hour on the freeway. She averages 15 miles per hour. So slow on the freeway. There is traffic. On her drive home, she averages 35 miles an hour. It's the traffic let up a little bit. If her total time is 2 hours, so overall it took me an hour to get there and back. How long does it take her to drive to the store? So I'm driving and I'm like, I'm gonna get a new iPhone 6. And so I get on the freeway, traffic. I'm going 15 miles per hour. So slow. So I finally get to the store, I get my iPhone, I get back in the car, and now I'm driving only 35 miles an hour. The average on the freeway is 60, 65, 60, 60. So I'm driving 35 miles an hour. So if it took me a total of 2 hours to get there and back, how long did it take me just to get to the store? So it's asking a round trip question. Okay? So for this type of problem, you're going to set it up the same thing as you did last time. Let's go back and look at the numbers we need. Alright, so 15 miles an hour is what I drove the first time. 35 miles an hour is what I drove the second time. Underline this with me. And it took me a total of 2 hours round trip. 2 hours there and back. Okay, so now I need to make myself a little key. Alright, so what do you want to call my driving time? What variable do you want to give it? F? Alright, F it is. Alright, so F is going to equal my driving time to the store. So then my drive home, it took me a total of 2 hours, and I'm going to do 2 hours minus how much it took me to get there. Because if it took me a whole 2 hours, and F is how much it took me to drive from the store to there, then the whole 2 hours minus that F should give me what's left over, what it took me to drive home. Okay? So 2 minus F is my drive home. So F plus 2 minus F should give me how much I drove home, right? So now I'm going to set up a little table. So I'm going to set up the drive. I'm going to set up the rate, how many miles an hour. I'm going to set up the time and the distance, just like the last one. Now what's that formula for distance? Distance equals rate times time. So I'm going to put a little multiplication sign there so I remember. Alright, so my drive to the store. How many miles an hour did it take me? What's the rate that I was driving at to the store? 15. Okay. My time, what did we indicate? What's my time? What letter?
F.
F. So what's my distance? Rate times time. 15 times F is? 15F. Alright? We're good there. So now I need my drive home. When I drove home, how many miles an hour was I driving? 35. What did we indicate is going to tell us that time? 2 minus F. So, what's my distance? Rate times the time. 35 times the quantity of 2 minus F. All I'm doing is multiplying rate times time. Right here, 15 times F. 35 times 2 minus F. Awesome. So now that we have our little table set up, I can figure out the equation. So I can figure out if I drew the first distance to the store, 15F, first distance, is that going to equal my second distance right here? So basically what you're doing is you're taking your two distances and putting them on each side of the equal sign. So 35 times 2 minus F. Do I need to do anything to the left side?
No.
No. Do I need to do something to the right side?
Yes.
What do I do? Distribute. Write down. So I have 15F equals 35 times 2 is 70. Bring down my minus sign. 35 times F is 35F. I need to get all of my variables to one side, so I'm going to add 35F to both sides. My negative 35F and my positive 35F cancel out. 15 plus 35 is 50F equals, and I'm up on the side of my 70. To isolate the variable, I'm going to divide by 50 on both sides. By 50 over 50. 50 over 50 is 1, so they cancel out. So I'm left with F equals. Now I know this whole zero trick, right? Those zeros are going to cancel out. So I'm left with 7 over 5. Well, I can't say that it took me 7 over 5 to get home. That doesn't make any sense. So I'm going to have to divide. 7 divided by 5. 5 goes into 7 once. I'm left with 5. 5 and 2 fifths. Can I say it takes me 5 and 2 fifths to get home?
Nope.
No. So what am I going to have to do? Do it into a decimal, right? So you could have done it this way and continued and made it a decimal. So you could have done 5 divided by 7, 1, get 2, add the decimal, put a 0 there, and bring down the 0. 5 goes into 24 times. So how long did it take me to get home?
1.4 hours.
1.4 hours. 1.4 hours. So my drive to the store was 1.4 hours. My drive back was 2 hours minus the 1.4. So that's what I did. It asked me how many hours it take me to get to the store. Cool. I know, it's a lot. Uno más. One more. This one is going to be called opposite directions. The last type you'll see. So we talked about same direction when we talked about the trains leaving from the same place. We talked about round trip, me going to the iPhone store. Now, last one we're going to talk about opposite directions. Jack and Jill. Gotta keep in. Jack and Jill leave their home traveling in opposite directions. Jack and Jill leave their home traveling in opposite directions on a straight road. The road's not windy, it's straight. They leave their house, opposite directions, but on a straight road. Well, Jack drives 15 miles an hour faster than Jill. Yeah, they're teenagers now. Jack drives 15 miles an hour faster than Jill. He's a speed racer. After 3 hours, they're 225 miles apart. find Jack's rate. And find Jill's rate. Find Jack's rate and find Jill's rate. So Jack and Jill, they're both like, all right, we gotta go. Jack goes this way, and he's 15 miles an hour faster than Jill. Jill goes this way. 2 hours later, or 3 hours later, they're driving 3 hours. It's like the length of you driving to Vegas with your parents, right? 3 hours later, they're 225 miles apart from each other. So we need to find how fast of a constant rate was Jack going and how fast Jill was going. Okay, so look back at the problem. Find your numbers. Jack is 15 miles an hour. Jill, we don't know. But after 3 hours, they are 225 miles apart. So we need a variable for Jack's or Jill's rate. So we'll give Jill a nice J for Jill. J equals Jill's rate. J is going to equal Jill's rate. Now, does Jack drive at the same rate as Jill?
No.
No. How does he drive?
15 miles.
He's 15 miles faster. So it's going to be Jill's rate plus what? 15. So Jack is J plus 15. He's 15 miles faster than Jill. So Jill is J, that's the rate she's driving. And Jack is her rate plus 15 more. She's 15 miles even faster than she is. So let's make a little grid. So we're going to label this kid, Jack or Jill. Rate, how fast they were driving. Time, how long they were driving for. And distance. So it's going to be rate, time, distance. So distance is rate multiplied by the time. So put a little X there so you remember. All right, so let's take Jill first. So let's write Jill. Let's analyze Jill. What did we say was her rate? Look at your key. What's Jill's rate? J. So with J, she drives at J. We don't know how fast she drives. Now what's the time that they give us in this problem?
3 hours.
3 hours. Do they both drive 3 hours? Yeah,
No.
so you just put 3. They're both driving for 3 hours. There's in opposite directions. So it's J times 3. 3J. Right, rate times time. All right, let's look at Jack. What did we say was Jack's rate?
Jill plus 15.
Jill's rate plus 15 because he drives 15 miles faster times. How long was he driving for? 3 hours. They were both driving for 3 hours. So distance is 3 times the quantity of J plus 15. It's multiplying those two. Awesome. So now we need to take both of our distances, put them on either side of our equal sign. No, it's not going to work for this one. In opposite directions, it told us in the problem that they ended up being 225 miles apart. So that's our equals. That's our total. So 225 miles apart is our total at the end of the day. That's how far apart they were. So now we need to see what their rate is. So we have 3J, which is Jill's rate, plus Jack's rate, 3 times the quantity of J plus 15. What do I need to do first on this left side of the equation?
Simplify.
Simplify. How? Distribute first. Okay? Distribute first. So I'm left with 3J plus 3 times J. Following my arrows is 3J. Bring down my plus sign. Follow my arrows. 3 times 15 is 45. All equals 225 miles apart. Now what do I see? Like terms right here. 3J and 3J. What's 3J plus 3J? 6J. 3 plus 3 is 6. 6J plus 45 equals 225. What do I need to do to both sides? Subtract 45. Write it down. My positive 45 and my negative 45 cancel. So I'm left with 6j equals 225 minus 45? 180. Very good. Divide both sides by 6 to get j by itself. My 6's end up canceling out on the left side because 6 over 6 is 1. So I have j equals 180 divided by 6 is 30. So wait, j represents who? Jill. So how many miles an hour was Jill driving?
30.
Okay, so Jill was driving 30 miles an hour. Now, if Jack was driving 15 miles faster, how many miles an hour was Jack driving?
45.
Yeah, 30 plus 15 is 45. He was driving 45 miles an hour. And that's your answer. They asked you to find the rate of each drive. So Jill drove 30 miles an hour, Jack drove 45 miles an hour. In 3 hours, they ended up being 225 miles apart. Go ahead and stop it.